Good day, students. Today, we want to describe an experiment to determine the specific latent heat or fusion of ice. In this experiment, there will be provision of calorimeter, water, stirrer, thermometer. They will be together in the calorimeter, and the initial temperature of water in the calorimeter is taken to be theta1. While the ice is dropped in the water, it melts from ice block to ice water because there is no difference in temperature, because the ice block is at 0 degrees centigrade. When it gets melted to 0 degrees centigrade, there is no difference in temperature. We use ml. But as it's gaining heat, it's moved from 0 to a particular temperature. I take it to be theta2. Now let's see the explanation of the experiment. Here is the calorimeter. It's being lagged. This lagging material. That's wood. That's water. The initial temperature of the water is theta1. That's ice block. This ice. This thermometer. Take the temperature. Thermometer. This is what we call calorimeter. You lag the calorimeter to prevent the heat loss to the surrounding. There will be stirrer. There will be lid to prevent the heat loss. There will be lid to cover the calorimeter. In this case, heat lost by heat gained by ice block equals to heat loss by calorimeter plus heat lost by water. And let's call it heat gain by melted ice. Let's call it melted ice. You understand? Heat gain by melted ice. Now let's call melted mass of melted ice. So let's call it Ni. Latent heat, specific latent heat, let's call it equal to L. Theta2 as final temperature. Let's call it final temperature of the melted ice. Let's call it theta2. Let's call initial temperature of the calorimeter plus water. Let's call it theta1. Now let's call mass of calorimeter equals to mCa. Mass of water, let's call it Nw. Now let's say mass specific capacity, specific heat capacity of water equals CW. Okay, now let's now start our analysis. The mass of ice, latent heat of ice, when it's moving from ice block at 0 degrees centigrade, now got melted to ice water at 0 degrees centigrade. There will be ml, no change in temperature, plus now when you start gaining more heat, turn to m, mass of ice, specific capacity of the water, it has turned to water, theta 2 minus 0, because coming from 0. Now let's now go to the other one, heat lost by calorimeter, mass of calorimeter Ca, so we use Ca to represent this, specific capacity of calorimeter Cca, let's call it specific capacity of calorimeter, specific heat capacity of calorimeter equals Cca. Now in that case, you have temperature change. Now in this case, theta 1 is greater than theta 2, because later when you drop the ice inside the water, the temperature of this will reduce to theta 2. That means that theta 1 is greater than theta 2. Now we have theta 1 minus theta 2 plus mass of the water, specific heat capacity of the water, the same temperature, theta 1 minus theta 2. They are together, the same container. Now you can be asked to look for the latent heat. And you now have ml equals, put all this one in brackets. Don't forget that this has turned to water. That's why we use specific capacity of water. It has turned from ice block to water. Now you now put all this one in brackets. MCA CCA theta 1 minus theta 2, close the bracket, plus MW CW theta 1 minus theta 2, close the bracket. Now when you take this one to the other side, become minus, open your brackets, write this, mass of the ice, the capacity of water, theta 2. Theta 2 minus 0 give you theta 2. Both side by mass of the ice. Mass of the ice. Therefore, the latent heat, the specific latent heat of fusion of ice, because MCA CCA, for your bracket, theta 1 minus theta 2, plus MW CW theta 1 minus theta 2, minus MI CW theta 2 divided by MI. This is the formula for the specific latent heat of fusion of ice. This is the end of our class. Please subscribe to my channel so that I can get the latest video. Have a wonderful day.